So if you look on so this is Unit 6, Learning Objective 5. This is to use the combined gas law to calculate the pressure, temperature, and volume changes in a gas. So if you go to your reference sheet, you will notice that I have given you 3 gas laws here. So I only give you 3 because you can actually deal with the others. So like Boyle, Charles, Gay-Lussac's laws are all tied within this combined gas law. So whenever you're using Charles Boyle's or Gay-Lussac's laws, you are going to be using this particular equation. When you're using Avogadro's law, you're going to be using the ideal gas law, and you're just going to take out the temperature and the pressure. And then this is a different law that's a little bit later on. Don't forget, you also have your healthful equalities that are over here for your pressure volumes. Remembering that your temperature, so degree C, to get degree C, you subtract 237 from Kelvin. So these are your laws that you can use on this unit. So Learning Objective 5 is to use the combined gas law to calculate the pressure, temperature, and volume changes in a gas. So the combined gas law combines Boyle's, Charles, and Gay-Lussac's laws. So remembering Boyle's law is P1V1, just one side of Boyle's law was P1V1. We know that that equals to P2V2. For Charles's law, we had V1T2. And then for Gay-Lussac's law, we had P1T2. So all of this kind of combines to get the formula we have on our periodic table for the combined gas law, which is P1 V1 T2 is equal to P1 B2 B2 V2 T1. And again, remember, this is where 1 is equal to the initial and 2 is equal to the final. So again, memorize what variable remains constant in each of these laws, okay? Because that means that you're going to take that particular variable out of the equation. So if it tells me in the problem that volume is constant, I'm going to take and I'm just going to cover up volume. So like volume is not going to exist in the problem for me. Okay, so I just take it and I kind of mark it out. So then I'm left with what Gay-Lussac's law is, which is P1T2 equals P2T1. And I know that that's Gay-Lussac's law because Gay-Lussac's law, the acronym for it is green veggies. Well, veggies is volume is constant. So then that means that that particular law would be Gay-Lussac's law. Okay, so any of these laws, you are going to use the combined gas law to solve for. And all you're going to do is take out whichever variable is constant, you take that particular variable out of the equation. And it'll tell you, add a constant volume. Well, if it's a constant volume, then you take out volume. Or it'll say add a constant temperature. If its temperature is constant, take out temperature. Okay? So then, combined gas law gives 2 sets of variables. So we have 2 pressures, we have 2 volumes, and we have 2 temperatures, or 2 temperatures. So essentially what's going to happen is you are going to be given 5 givens. So you have 5 things that are given to you. That's going to indicate that you are using this equation. So let's look at a problem here. I'm going to highlight all of the different variables in 2 different colors. So this bright blue color will be my initial, and then I will highlight in pink for the final. So a sample of a gas has an initial volume of 158 milliliters at a pressure of 735 millimeters of mercury and a temperature of 34.5 degrees Celsius. That is all my initial stuff. If the gas is compressed to a volume of 108 milliliters, heated to a temperature of 85 degrees Celsius, it's asking me what is the final pressure in atmospheres. So there's going to be a couple of things that I have to do here. So I have been given, first off, write out your equation. So I've got P1, V1, T2. That's equal to P2, V2, T1. I am looking for the final pressure. So I'm looking for P2. So I'm going to box in what P2 is. Now, when I box it in, it's not going to move. But I'm going to have to divide by V2 and T1 to get rid of those two on this side. And then whatever I do to this side of the equation, I have to do to this side, to the other side of the equation. So I'm going to divide by V2, T1. And this becomes my formula now. So P2 is equal to P1, V1, T2 over V2, T1. So then now I need to go through and label everything with what all this stuff is. So if I look here, this is going to be V1. This is P1. This temperature here is T1. This is V2. And this is T2. Now, one thing that I'm going to have to do with my temperature values is convert them into Kelvin. So, writing all this stuff out, I'm going to move myself over here. Writing all this stuff out, I have volume 1 is equal to 158 milliliters. Pressure 1 is equal to 735 millimeters of mercury. Now, I need my final pressure in atmospheres, so you can go ahead and convert that now, or you can convert it after the problem is finished. I'm going to go ahead and choose to do it now, so all I have to do is divide by 760 millimeters of mercury, because that's equal to one atmosphere. My T1 is equal to 34.5 degrees Celsius plus 273. So this is all my initial stuff. My V2 is equal to 108 milliliters. Now, I need to make sure that my units here are the same. They are, so I don't have to convert anything. If they were different, I would have to convert. I don't know P2, so P2 is the question mark. And my T2 is equal to 85 plus 273. Kind of plugging some of this stuff into my calculator. I have 735 divided by 760. That's equal to 0.967 atmospheres. This is equal to 307.5, 358. Now remember, this is Kelvin and this is Kelvin. Now remember, you're switching these two, so this T2 goes with these things and T1 goes with these things. So then plugging it into my formula, I get P1, which is 0.967 atmospheres. times V1, which is 158 milliliters, times my T2, which is 358 Kelvin, divided by V2, which is 108 milliliters, also divided by T1, which is 307.5 Kelvin. Now, if you notice here, I have, if you notice here, Kelvin is canceling, milliliters is canceling, and I'm in atmospheres, which is what I want to be in. So then, going to my calculator, plugging this in, 0.967 times 158 times 358 divided by 108 and divided by again, because both of these values are on the bottom. So because both of these values are on the bottom, we're going to hit divide 2 times. So 307.5. That's equal to 1.65 atmospheres. So 1.65 atmospheres, that is our value for my thing. Now, I want to make sure that that makes sense. So I'm decreasing my volume. So my volume decreases. That would cause an increase in pressure. And I'm increasing my temperature, which also causes an increase in pressure. So as long as I got an increase in pressure, which I did, because my initial value is 0.967 and my final value is 1.65, this makes sense. So I know that that has to be right. If I got a smaller value here, then I would know that my answer is not right, because based on what is happening at my pressure, at my temperature and volume. So based on what's happening at my volume and temperature, my pressure should increase. And if this does not have a higher pressure than my initial pressure, then I know that I did something wrong in my calculation. And most likely what you did wrong is you switched your temperature values. You put your 1 with all your 1 stuff and your 2 with all your 2 stuff. Just remember, 2 always goes with 1, 1 always goes with 2 when it comes to temperature. Okay, so this is learning objective 5. Use combined gas law to calculate pressure, temperature, and volume changes in a gas.